Hey guys, welcome to another video. Today's learning objective is to explain the concept of gradient and y-intercept and to be able to find the equation of a line through two given points and through 1 point and a given gradient. Okay, as usual, feel free to skip to any part of the video. There's a couple of worked examples here. The first one is about solving this question about the equation of a line through two given points, and the second one is finding out the equation of a line through 1 point and a given gradient. Okay, before we get started, is there any prerequisite knowledge that we need? Yes, it's kind of important to have known and understand the previous videos in terms of remembering what a line is and how it's the equation which every point on that line satisfies, and just remembering what the graph is in terms of being two number lines. So yeah, but let's get into it. Okay, so remember last time we talked about this concept of the slope, which like that, and how the slope can change of a line. Well, there's actually a formal mathematical way of measuring the slope, which I mentioned last video, is called the gradient. And the formula for the gradient is saying what we do is, if we take 2 points, let's say this point and this point, if we find the change in y, which is okay, wait, let me just draw an arrow, the change in y, which is this, and then we divide it by the change in x, which is this length here. And that way we can that's what the gradient is called. So if we call this change in y, well, change is a mathematical way of saying it, which is this triangle. It just means delta means change. It's just a Greek letter that we use, so that means change in y is change in x. And the gradient is equal to change in y over change in x. One way, if you get confused between which one's on top, which one's on bottom, you can think of it as rise divided by run. That's one way of thinking of it. And so if we put some numbers on here, let's say this is 5, 10, 15, 20, and this is, say, again 5, 10. Well, we know to go from this point to this point, the change in x, so actually let's do change in y first. To go from this point to this point, the change in y is delta y is equal to 10 minus 5, which is equal to 5. And the change in x is equal to 20 minus 10, which is 10. Therefore, the gradient is equal to 5 divided by 10, which comes out neatly to a half. And if you remember how I talked about the general equation of a line in the last video, y equals mx plus c, well, this m here is just the gradient, and to see why this abstract change in y over change in x somehow pops in like this, there's a bit of an intuitive proof behind it, which I think it's worth going over. So say you're starting off when x is 0. So in that case, well, y, when we say, let's say x is 0, y is equal to c. And now let's suppose x goes up to 1. In this case, y will go up to m plus c, right? And now we've got two separate points. And if we've got these 2 points, we can find the change in x and y and find the gradient. So the gradient, we know, is change in y, which is c. So this is, the second point. Equals m plus c minus c divided by change in x, which is 1 minus 0, which is equal to m over 1, which is just m. So you can see why the gradient is equal to m. So that's just it's important to know that. So that's what the the m in this equation represents. Or so if we can think about it, the larger the m, the more the gradient, or the higher the gradient. And if you think about higher gradient, that means the y changes more for the same amount of x, so i.e. gets steeper. So you think of a line, say line like that, right? So if x goes from, say, I don't know, so from 5 to 10, we can see how y has changed by, let's say that's that's like 18, maybe, yeah, something like 18. So the change in y is something like, let me write 18. So the change in y is equal to 18 minus 8, and the change in x is just from 5 to 10, which is so 10 minus 5, which is 10 over 5, which is 2. So we can see that the higher the gradient, the steeper the line is, and kind of the smaller the gradient, the shallower the line is. And of course this applies to negative gradients. So we have a kind of a line like this. Again, so that's kind of, let's say it's y equals minus 2x, the equation of that line. So kind of the bigger the number, this number, the steeper it is. Obviously, say the number minus 10 is actually smaller than minus 2. So we can't say the bigger the gradient, the steeper the line all circumstances. Kind of with positive gradients that makes sense, but with negative gradients, we can kind of say that the larger the magnitude of the gradient, which means kind of the number itself, ignoring the sign, the steeper the line. And now that we've talked about a bit of the gradient, we know how to find the formula, right? Find the gradient from kind of 2 points. If I was to ask you, for example, to okay, well, actually, wait, hold on, look into that. If we say, find the gradient between the line, a bit of the line that passes through the points, say 7, 8, and 12, 15. Well, we'd say gradient is equal to change in y, which is 15. This, we look at the second one, minus 8, divided by 12 minus 7, which is 15 minus 8 is 7. 12 minus 7 is 5, which is 7 over 5. And kind of the common mistake students do is sometimes what will happen is that you'll do 15 minus 8 for the change in y, but you'll do 7 minus 12 for change in x, and in that case you've got the sign wrong. What you need to do is effectively what you might want to do is say label this as 2, label this as 1, just to remind yourself you do 2 minus 1, so you'll do 15 minus 8 and 12 minus 7, not to get that confused around. Okay, so I've kind of cleared some of the stuff away, so we can talk a bit more about the y-intercept now. So remember, if we go back to the equation of the line, we talked about y equals mx plus c, right? And now we've established that m is the slope, or the gradient, which is the correct term. And remember, we talked about how c meant how much the line would shift up or kind of shift down, right? That's what c represents, kind of this up and down thing. But if let's look at what the number c itself is. Well, when x equals 0, right? So x equals 0, well, y is equal to c, right? Because that's m times 0 is 0, m plus c is just c, right? So this is what we call the y-intercept, because if we look at the y-axis, when x is 0 and what y equals, that's a point at which the straight line intersects the y-axis, so that's why we call it the y-intercept. So we call that the y-intercept. And that's kind of the way we choose to represent how much is saying by how much the line has gone up or gone down, as just as a way of it's a bit easier to use this plus c, because it just makes writing our equation a bit easier, because we just say when x is 0, this is what y is, so this is what this number up here is. And that's all there is to what c is. It's a bit easier, I guess, to wrap your head around than what the gradient is. And so I hope this makes sense in terms of why this is the equation of the line. Just to recap real quick, there's only 2 things we can change to make a line. So we can change by how much it goes up and down, or how the slope changes. And once we can describe those 2 things, if we say that the gradient is, say, 3, and the y-intercept is, say, 7, well, we've only got one line now. And now, by having those 2 things, we uniquely describe that line. And we can do it in this form, which just is a nice, easy form that we can write it in. This isn't say the only form of writing the only form we can use to write the equation of a straight line. It's just a very helpful form. We could also write the equation of a straight line and say y minus c all over m equals x. The thing is, this is just a bit harder to understand. Now, we have, say, x is equal to y over m minus c over m, and we can do y over m minus, say, I don't know, this will just be some number, say d. And now, when you see an equation, when you just see the equation of a line now, if I showed you an equation of a line y equals 2y minus d, you'd kind of struggle a bit more to think about, okay, hold on a second, what's the gradient? Okay, 2 is here, so that means the gradient is 1 over 2, which is a half, and the x-intercept, the y-intercept rather is, you know, whatever this number is, and then you kind of, it's just a bit harder, right? You can see how this is just a more useful form of the equation of a straight line, and it's kind of the form that we usually kind of refer to. Sometimes in questions it'll actually ask you for the equation of a line in another form, but kind of in this form it's the easier way because we can have our two kind of really important values, gradient and y-intercept, kind of very easily seen and very easy to read. So yeah, let's move on to a worked example. Find the equation of a line passing through 419 and 728. Again, so remember there's two key pieces of information we're interested in, the gradient and the y-intercept. And to do what we do first is to find the gradient, which just means kind of finding the y-intercept will be a bit easier. You'll see why in a second. So what we do is gradient, that's the first thing we do, we say gradient is equal to change in y over change in x. What I like to do is kind of say, you know, label this 1 and 2. Okay, so change in y is equal to, so we look at the second number. What I've done so many times is I've kind of, you know, confused my x's and y's and lost so many marks for that. So we look at the second number, 28. Again, the second number in the first bracket, minus 19. And then we look at, I'll change colors, oh, maybe orange. And then we look at number 7, second number, and then, sorry, not first number, but in the second bracket, and then first number in the first bracket, which comes out to 28 minus 19 is 9, 7 minus 4 is 3, which is 3. And now, since remember, we know the equation of a line comes out into the form of y equals to mx plus c, and we know the gradient is 3, well, we know m is now 3. So now we know y equals 3x plus c. And now we can find the y-intercept. We can find c. So remember how I said kind of a line, kind of the equation of a line, it satisfies all the points on that line. It's true for all the points on that line. So that means when you plug 419 in or 728 in, you should get this to be true. So if I was to say if y is 19 is equal to 3 times 4 plus c, so we can kind of just rearrange this and solve. If we haven't, I don't think we've covered this stuff explicitly yet. It will be covered a bit more kind of extensively in future videos, so kind of keep your eye out for that. But yeah, so I'll kind of just walk you through what we do here. So y is equal to 19, so 19 equals 12 plus c, and if we take away if we minus 12 from both sides, c is equal to then 19 minus 12, which is 7. Therefore, y is equal to 3x plus 7. You can see kind of if we do it this way, there's a very prescriptive and kind of a formulaic method to it, which just kind of works every time. If you have these 2 points, first thing you'll do is you'll find gradient. Second thing you'll do is kind of you put it in this form, and then you'll plug in one of the 2 points to find c. And of course, we can check if it satisfies the second point. Okay, 28 is equal to 3 times 7 plus 7. Is that true? 3 times 7 is 21, plus 7 is 28. So it's true. So kind of the equation of the line works for point 1 and point 2, and if it works for kind of those 2 points, there's only one equation of the line that goes through those 2 points. Or I mean, you know, you could say it's, you know, another equation of the line could be 2y is equal to 3x plus 14. We just kind of multiply both sides by 2. But kind of we can simplify this form into that, and this is kind of the preferred form we like it in. We like to have the equation of the line in the form of y equals mx plus c. As I said, because that's the easiest form and kind of the most conventional way of doing it. You know, I think I'll do another one just in case to kind of make this part clearer. So say, you know, find the equation of the line through, say, I don't know, 14, 7, and 18, 9. I've got no idea what this answer is going to be, so I guess I'm working through this for the first time as well. So again, first thing we do, gradient, so change in y. So we look at this second number, so I'll do 1, 2 as usual. So we do 9 minus 7, change in y, over change in x, 18 minus 14, which is 9 minus 7 is 2, 18 minus 14 is 4, which is a half. And so we can write equation of line is equal to y equals a half x plus c. We know kind of both of these points has to satisfy it. So we can say 14 is equal to 7 over 2, so half times 7 plus c. If we minus 7 over 2 from both sides, the equation stays true, right? We've done the same thing to the left and to the right, so the kind of equality stays there. So we can do minus 7 over 2, minus 7 over 2 here. So the right hand side just becomes c, because the 7 over 2 minus 7 over 2 becomes 0, so equals c. And then on the left we have 14 minus 7 over 2. And then we can say therefore c is equal to, so again we need common fractions for this to happen. So 14 is the same thing as 28 over 2 minus 7 over 2, which is 28 minus 7 is 21, 21 over 2. And there we go. That's how we do that. Now let's move on to another kind of question that comes up. Find the equation of the line with the gradient minus 3 and that passes through this point. Okay, well, this is kind of a bit easier than the previous question. So because they've already done the gradient for us, we just have to basically do steps 2 and 3. So why don't you pause the video, kind of give this one a shot and see what happens. Okay, so we can write gradient equals minus 3. And so we know the equation of the line is equal to y equals minus 3x plus c. We know this will be true in this equation because kind of that's what the equation of the straight line is, right? It has to satisfy every point on that line. So you go 8 is equal to minus 3 times 3 plus c. 8 is equal to c minus 9. Let's add 9 to both sides. So kind of the minus 9 and the 9 goes away. And so on the right we have c, on the left we have 9 plus 8, which is 17. Therefore c is equal to 17. And there we go. And see, the thing is sometimes you see, oh, c is 17 and you think you're done. I think that's actually what I did over here, didn't I? What you need to do, so even over here, right, I just left it in this form. What you're really supposed to do is say, therefore equation of the line is a half x plus 21 over 2. You shouldn't just leave it in this form. That was kind of a mistake from me. And the same thing here. You don't just leave it like this. It sometimes feels like, oh, I'm done. But what's really important is to remember to go to y equals minus 3x and just put it in this form. So you can say, therefore, equation of line. And kind of, if you've seen me use this before, this just means therefore, kind of with mathematical notation. It's just a triangle made up of 3 dots. But yeah, that's just kind of some mathematical notation. You don't have to use it, it's completely optional. Just something I've gotten used to using now. But yeah, so I hope that made sense. Just as a quick recap, what we covered was kind of the gradient and the slope, and those are kind of remember, those are the 2 key ways of defining a line. Once we have those 2 numbers, we kind of only have one kind of line, so the gradient, which is kind of the slope, and the y-intercept, which means kind of how far up and down it goes. And with those, there's kind of a neat way of writing them in the form of y equals mx plus c, where the gradient and the y-intercept are really easily visible, which m, remember, is the gradient, and c is the y-intercept. And since this is kind of a very nice way of writing it, this is kind of the way we usually follow, and kind of most of the questions expect you to write it in this way, unless they kind of specify otherwise. But do remember, there are other ways of expressing it, but this is the best, or not the best, but most conventional and kind of a very useful way. And now that we have that, it's kind of, once we can find, so now that we have that kind of equation, it's really easy to plug in numbers. So once we find the gradient, we can just plug in the gradient here, and then we can find c by solving the equation, kind of by putting any point we have in it, sticking that in, and just we can then find the equation of a straight line. But yeah, kind of hopefully that all made sense. If this is kind of new to you and you're just hearing this for the first time, quite important to do questions on this. especially kind of wrapping your mind around what the gradient is, kind of how the slope is important, and how kind of moving up and down makes sense. And sometimes what's worthwhile is kind of, the kind of intuitive reasoning I've given you is if kind of, you stop the video now or whatever, or at the end of it, and then you just take a couple minutes and try to remind yourself of that intuitive reasoning. So get a pen and paper out and just explain to yourself, why m is the gradient, what the formula of the gradient is, that kind of stuff. And that would just mean that that ensures that you remember it, and just means that you've kind of got to grips with it. But yeah, see you guys in the next video.